Hi everyone, now we will solve a few examples about ordering things permutation. So 3-digit number we will do from the set without repetition. That means we cannot use the same number once again, same digit once again. Here we have 1, 2, 3, 4, 5, 6, 7. So for the first place we have 7 options, and 6, then 5. 6 times 5, 30, times 7, 210. This is the all different numbers that I can get. Whatever answer I have in ABC, it should be smaller than 210. Okay? So how many numbers do not contain the digit 5? So in here, in 210, that means we have the options 134, 135, 137, 138, 13 something, 13 something. So 210 numbers that I can create like this. So from these 210 numbers, how many of them do not have the number 5 in it? So to calculate for the A, you just remove the number 5 from the choices and try to create another 3-digit number. For the first place, 6, then 5, then 4. 5 times 6, 30 times 4, 120 numbers. They don't have 5 inside, they don't include the number 5. So for the B1, how many numbers contain the digit 5? So this, I put them next to each other because of a reason. Because when it says including the number 5, sometimes we solve the questions from opposite behavior. We say that all possibilities minus none, minus the opposite. Which is, we can create 210 numbers, which is all possible numbers. So 120 of them are including 5, which is opposite of not including. Opposite of not including. So that makes how many? 90? 90 numbers. They don't have number 5 in it. A, B, C. So how many numbers contain 1 or 7 or both of them? So in here we will again use all minus none, which is we should find how many numbers has no 7, no 1. Let's do it with another color so you see the difference. We remove the options 1 and 7 to create a 3-digit number. So without 1 and 7, we have 1, 2, 3, 4, 5 more options. 5, 4, 3 numbers. 5 times 4, 20 times 3, 60. From all 210, subtract 60. That makes 150. In 150 numbers, you have sometimes only number 1, like 138. Sometimes you have both of them. Sometimes you have only 7, like this, 789. So then the other example, so ordering the books on a shelf. So if you order them without caring, you just add the 5 math ones. Also, it is important that if it writes same math books, like the ones that we are using, like Mathematics Volume 1, Mathematics Volume 1. If they are all the same, even if you change their places inside each other, they will mean the same order. But right now, they are all different. 5 plus 3 plus 4. We have 5 plus 3, 8 plus 4, 12 books. So for the first place, we have 12 options. Second place, 11 options. Third place, 10 options. Fourth place, 9 options. That makes like the permutation. We have 12 place, we want 12 books, and we want to order all of them. It will be simply 12 factorial. First, second, third, fourth place. It is hard to write like this. That's why I use the quick idea. So then, in 3 different file holders, in each holder for a different subject. So you will put the math notebooks next to each other, then biology books, then physics. In here, the idea, inside the math books, they can change places. So we have 5 math books, and they can change places inside each other, like permutation 5, and we want to order all of them. Times. For biology, how many do we have? 3. Then 4. Physics, how many do we have? 4. So you will multiply all of these options. We also have, so in this order, I did put the math first. What if biology is the first? What if physics is the first? So the groups can also change place inside each other, the groups. That's why here we have 3 groups and they can also change places. That makes 5 factorial for math books, 3 factorial, the different orders that we can make, then 4 factorial for physics books, and for the groups, we have 3 groups and 3 factorial for the groups. Thanks for listening.